And so this one's also calculator active. When the popular streaming service Netflix was founded in 1997, they were a mail-order DVD subscription service. I don't know if you guys knew this, but I lived through it and remember this well. As the demand for renting DVDs rapidly diminished, Netflix transitioned into a streaming service. In 2007, which they're going to call T=0, Netflix launched their new streaming service with 7.32 million subscribers. By 2015, T=8, Netflix had grown to 70.83 million subscribers. The number of Netflix subscribers can be modeled by the function n, given by n of t = a times b to the t, where n of t is the number of subscribers in millions for year t, and t is the number of years since the initial launch of Netflix streaming service in 2007. So this is going to be an application problem, so it's going to be in context of a real situation or real-ish situation. In this case, I think this is a very good application that he's pulled out that we can kind of all relate to here. It's going to be like fitting points to a curve problem. Now, what's going to change about this from question to question is this form right here. He has asked us to do basically a straight exponential on this one, right? It's just a regular exponential problem. It may not be an exponential. It can be a polynomial, so it could be like a quadratic. It could be some type of log regression. It can be an exponential that has like a little bit different thing going on, like there might be a plus c or something on the end. I'm trying to think if there's any other options. I'd have to look through and see. There won't be trig in this part. Trig will be in the other parts. Here, so this can change, but the process for the problem stays the same. So, part A, number 1, we've done several of these questions. Use the given data to write 2 equations that can be used to find the values for constants A and B in the expression n of t. Okay, so no matter what, this right here is what you need, and you need to know your points. So my points here are going to come from up here. I've got in 2007, T=0, Netflix had 7.32 million subscribers. I would not change this to millions here. I'd use 7.32 and just put millions on my answers. It'll be easier to work with. So that means I've got the point 0, 7.32. This is a t value. This is an n of t value. Okay, so what you're doing here is, I'm going to write this down and then erase some. You're taking this equation, or whatever equation it is. It might be a different equation on different problems. The 2 that I'm going to give you tonight will be different equations than this. You take this, and you are replacing the t with the value that you have here. So that would be a 0, right? So we're erasing the t. We're putting the 0 there. And then the n of t is 7.32. So we're erasing the n of t, the whole thing, and we're putting 7.32. You're like A, B, and possibly C. There might be a C in the problem as well. Those are the letters you want to keep in the equation, right? You want to replace it's usually a T and a N of T, P of T, S of T, something like that.
Would you also replace the T since the T and the other multiplied, but not 0?
They're not multiplied. So N of T is your function notation, so it does not mean N times T in that case. N of T is like a variable in itself. You can kind of think of like replacing it with a Y, right? So like that Y coordinate replaces that whole expression. That's a good question though, because that could be a confusion there. So whenever you have like N parentheses T, it is not N times T. It is N of T function notation, which is really just like the Y coordinate. Okay, All right, so that's our first one. We're just going to do the same thing with our other point. So our other point is at t equals 8. We have 70.83 million subscribers. So that is the point 8, 70.83. Okay, and same thing. N of t gets replaced with our y coordinate, our N of t coordinate right here, which is 70.83. We leave the A, we leave the B, we're not replacing those, and then our t gets replaced with an 8. Okay. Then it tells us to find the values for A and B. Mr. Passwater has a note here that says sometimes you can use regression to solve for A and B. I'm going to say you can use the regression to solve for A and B. You just have to know how to do it. Be careful. You cannot always use the drop down menu. On this particular problem, you could use the drop down menu because a times b to the x power is the programmed exponential regression. So you can show, work, and solve this by hand if you want, but there are no prizes for that. So I would use the calculator for this. So let's everybody type this in. So go get your computers. I'll make sure we're good on this. So we want to add a table, and we're just adding these 2 points, 0 and 7.32. and 8 and 70.83. I want to make sure everybody knows how to do this without the drop-down box because, like the 2 I'm going to give you tonight, you can't use the drop-down box for. Okay, so I'm just graphing those 2 points. As I said, drop-down box works on this one because the exponential is one of the programmed regressions. However, it does not always work. In fact, like the 2 I'm going to give you for your assignment tonight, the drop-down box does not work. So let's talk about what you need to do if you are going to use the squiggle. Okay? Because I want to program us to just use the squiggle because it'll work every time, even you're not going to pick the wrong one. There. So, start with that equation that they give you, right? So, whatever equation that they give you, we're going to start with that. But Desmos does not allow you to put in the t and the n of t, right? Not in that table. Desmos has x1 and y1. Okay? So, this piece right here, whatever is in that y-like position right here, your function notation, you're going to replace it with y1. You're going to leave the other stuff alone, a times b, much like you did in your equation up here, right? Actually, and then you're going to replace the t right here with x1. Okay, and then there's one more thing that I should have replaced here. You're not going to use the equal sign. You're going to use the squiggle sign. Okay, so if I go down here and I do y1 squiggle a times b to the x1, to type y1 or x1, you just type y with 1 behind it, right? And then it will give you your values for a and b. So all you have to write down here are a equals 7.32, and B equals 1.32805. Technically, you only have to keep 3 decimal places. I would keep them all here for this. Okay, everybody good here? What's going to change in this equation is that like equation that you're starting from. Now, on this particular problem, you could have done exponential regression right here and it would work because this is of the form a times b to the x power. But you'll see, like, if I want to do a log regression, it won't let me because, let me try a quadratic regression. It is ax squared plus bx plus c for that. If you don't, like, if you have a different form of that, even if it is still a quadratic, it's not going to do it correctly. So we probably really are better off just sticking with the squiggle because it works every single time. Okay, everybody good here? All right, so this middle part, we've done some of these too, is going to talk about use the given data to find the average rate of change. Okay, when you see average rate of change, what should you be thinking? Average rate of change. That's linear. And we're looking for slope. Okay, you have to completely ignore in all of part B that this is an exponential equation. We are treating it like it's linear in part B whenever they say average rate of change. So we're just finding the average rate of change. Express your answer as a decimal approximation. Show the computations that lead to your answer. If they tell you it's got to be a decimal, you have to give the decimal. You can't leave it as a fraction. So in this particular case, you're using those 2 points that we had up here. So you're doing 70.83 minus 7.32 over 8 minus 0. And then you are going over to Desmos, and you're just typing that in. 70.83 minus 7.32 over 8, and we'll get 7.93875. Again, you don't have to keep 3 decimal places, but it's fine if you keep more. Did I type it in wrong? Okay. Okay. In this part, that's all you have to have. I think it is somewhat helpful. At least 3 on everything. So anything you're writing out, at least 3 decimal places. You also do not want to round during the problem. So like, it is okay if you say B equals 1.328, but when you use it later to find an answer, don't use the rounded version. Use the exact version to find it. Yes?
The answer I put down 7.938 instead of 7.939.
They'll technically take it. 7.938 is not good rounding, but they will technically take it on the AP exam. So it's not something to get too worried about. It would not be the best practice because you should round that 8 up to a 9 if you're rounding it off. But the test is designed to see if you know how to do pre-calculus, so they don't want to dock you a whole entire point for cutting that off. But now if you round it to 7.93 or 7.94, they will not give you the points. So, I mean, they do draw the line somewhere, but they're a little bit forgiving. If you just cut it off, they do still give you the point for that. But it's not the best practice. Okay? Now, you don't have to put units here, but I think units are helpful to help you on the next part. So you can include them here or not. So 70.83 and 7.32, what are those? Those are subscribers, specifically million subscribers, right? So this is million subscribers. And then what about 8 and 0? What are those? Those are years. So this is million subscribers per year. Okay. Yes.
Would you have to, so you don't have to put years since 2007?
No, not here. Because the rate of change, it really doesn't matter where you subtracted those, like whether we call it 2007 to 2015 or whether we call it 0 to 8, it's still 8 years, right? So, so for this part, you do not have to specify that that's year since 2007. You just would have million subscribers each year for that. Mr. Passwater has made us sort of like a sentence structure that we can fill in. It doesn't have to be written this way, but this is a good way to answer this question. So start with, on average, the blank increases or decreases by so many units from t equals blank to t equals blank. So if we're writing that here, we would say, on average, the, what are we talking about here? Number of subscribers. So number of subscribers. Is the number of subscribers increasing or decreasing? Increasing. Increases. By 7.93875 million subscribers per year. And then here's what a lot of you guys were leaving off on these types of problems. You have to tell the time frame for it. I would say we were doing t equals 0 to t equals 8, but what real years was that? 2007 to 2015. If you say from t equals 0 to t equals 8, they might forgive it, but we want this in context of the real world, so it's best to go with the real years on this. So don't forget that time frame. A lot of us a while back when we had that like exponential and log test, a lot of us were forgetting to put that time frame when it happens, because this is not the case everywhere, it's just during this time frame. Okay, so this is a good thing to look back at if you're unsure of how to answer a question like this, right? Okay, an alternate part 2 that they may ask you. They may not ask you to describe it in context. They may ask you to use this to estimate the subscribers at a certain year. The biggest problem we have here is that we want to go use the exponential function, right? Because they told us it was an exponential function, and now they're telling us to use average rate of change, right? But it says use the average rate of change, and that means you have to treat this like a linear function, right? You're treating it like it's a line, not an exponential or a log or whatever else they told you it was at the beginning. So, so at t equals 6 years, we need to figure out what is happening. So here is what you're going to do. You're going to take a given amount plus your average rate of change times the time that passed, right? Some of you make a table here. You make, like, you will do, oh, we had, this is not the easiest, this is not a good table problem because the numbers aren't whole numbers. So, but you might say, oh, we started off at 7.32, so like at 0 we had 7.32. And then at 1 we're going to add to it, right? And do a table all the way till you get down here to 6. That'll work. That's fine as long as you show your work on that. This is not a particularly easy problem to do that with because you've got such big decimals that you're having to add every time. But you could do a table where you just show it 0, 1, 2, 3, 4, 5, and then you're just adding that average rate of change at 7.9, whatever, each time till you get to your answer. I would take 7.32, and you need to show your work, even though this is a calculator active problem. You need to show the grader what you're typing into that calculator. So 7.32, that's what we had at t equals 0. And then each year we're adding 7.93875. So 7.93875 times how many years from t equals 0 to t equals 6? 6 years. It's not always that number 6 because, like, maybe sometimes we start at 2, right? If it was 2 to 6, we just multiply by 4 right here. And so this part, once you have this written down, you can type this into the calculator. You do not have to show any work by hand here. 7.32 plus 7.93875. I would not round that off. I would keep the whole decimal right there. And we got 54.9525. And I put million subscribers. And I would probably put in or at t equals 6. And it's going to be this formula every time. Given amount plus average rate of change, which is your slope, right? Times your time that has passed between that given amount and whatever they're asking you for. Okay. I don't know that I have given you a problem like number 3. So let's think through this one. I think, I can't remember if it was last year or the year before, there was one like this on the exam. And it was not, like, the score report doesn't tell me what you answer individually, but it'll tell me, like, how our class did overall on this. And this is not one of our best ones because it is a little bit wordy. It says, consider the average rates of change of n from t equals 8 to t equals p years, where p is greater than 8. Are these average rates of change less than or greater than the average rate of change from t equals 0 to t equals 8 years found in part 1? Explain your reasoning. Okay, so in general, you need to think about the shape and behavior of the graph of our model and use that to help to understand this. Okay, so we're thinking about, like, they told us this is exponential, right? Is it exponential growth or exponential decay? Exponential growth. So exponential growth is going to look like this. It's going to start off slow at first, and then it shoots up. And so let's say this right here is our 8, maybe, right? It doesn't really matter where you put that 8. And then it tells us we got another letter P where P is greater than 8. So P is somewhere over here. P is a bigger number. We don't know what number it is, but it's a bigger number. Okay, so what we're considering here, average rate of change is our slope. So from 0 to 8, I've got this slope right here. If I think of the average rate of change from 8 to P, I've got this slope, right? Which one's bigger? From 0 to 8 or from 8 to P? 8 to P, right? Because that line is much steeper right there. Okay? It is going to help you, I think, to draw something like this. Okay? Then, I would say, since this situation is modeled by exponential growth, and that model is concave up and then right here's where I start using their language. Okay, so they're saying, are these average rates of change less than or greater than the average rate of change from 0 to 8? So I'm going to say the average rate of change of n from t equals 8 to t equals p is, so 8 to p, that is greater than the average rate of change of n from t equals 0 to t equals 8. There. This is not always what they ask you on part 3, but it is a typical thing that they may ask you for part 3. And in general, it's usually concavity that you care about, right? It's usually, like, because if the graph is concave up, you're increasing at an increasing rate. So your rates are increasing, right? Or you could be decreasing at an increasing rate. Mm-hmm. Yes. So what we got, Evan? Let's look at what Evan has, although I put it up there. I don't know if you won't be able to read that. But, given that the function is described as exponential, we can be sure that the function will constantly increase the rate of change. So the rate of change will be bigger for p is greater than 8 compared to, now this notation right here, you do 0 less than t less than 8 right there. So you t in the middle there. The only thing I would do different right there, Evan, instead of saying that the you say will constantly happy, then you can make that conclusion there. So I think yours would be pretty good, except for I would change that one phrase. Okay? All right. Part C is going to go back to the exponential model. Okay, so you're not using average rate of change. So we're back to model from part A. So that middle part is all like linear, right? C goes back to the model, the exponential. So for which t value from t equals 6 years, for which t value, t equals 6 years or t equals 19 years, should we have more confidence when using the model in? Give a reason for your answer in context of the problem. Okay, so this part is going to ask us about some sort of restrictions on our model. It might talk about how we should limit the domain or the range for the model. In this particular case, it's asking us about the confidence. So I'm going to do this. I'm going to go over here. I think this will be insightful here. I'm going to type in x equals 6 and x equals 19, and that's going to put me 2 lines right here. Let's see. Oh, gosh. All right. So at 6, I can see that I had, sorry, I got too many things going on there. At 6, I had 40.15972 million subscribers, right? So that'd be like 2013 there. At 19, I've got 1,605.3259. Let's see, and 19 is that this year? It is, isn't it? That's lucky. Let's go Google the number of Netflix subscribers right now. Let's see. The AI answer says 325 million. That says 301 million. I was thinking it was a billion too, but the AI is telling me 325. So, if that's right, that was a quick Google, and I'm not going to spend any more time on it than that. If that is right, then our guess right here, that's too high, right? We should be getting 325. Why? Why is that not great? Right, like exponential patterns may not last forever. This is further outside of the data, right? I'm interested to see how Mr. Passwater, oh shoot, I think I closed that out. I'm interested to see how Mr. Passwater words that. I need to close that one. Oh, one thing. Get it together here. Oh wait, maybe I didn't have that one open. I need, where's it at? Do I even, I don't think I've got the key on this. I'd have to go search forever. I'm gonna give you what I would say, and I'm gonna double check and make sure it's okay. Since I would say since 6 falls within the domain of our data set, and 19 is further outside of our data, we can have greater confidence when using the Model N for t equals 6 years. And if you get asked some version of this question, the one that falls within the data is always the one you want to answer for that. Anytime you start to go way outside of your data, you get crazy answers. If you remember that activity we did where I had some of you putting the Hershey Kisses in the boxes and some of you trying to figure out number of, I can't even remember everything that we did, number of the dominoes you could stack, we extrapolated that to a huge number and we had some wildly different answers, right? So it works well for inside your data range and maybe slightly outside, but it's probably pretty inaccurate when you start expanding that to further out. Okay, so let me give you